Hello everyone. So today we're going to go over the last part of the Unit 10 practice test, the problems part. So here we have problem number 1. A beam of light is reflected in a mirror. Its intensity is reduced by about 10%. So we are to determine a function that models the percent of light that remains after a beam of light has been reflected in n mirrors. So we can have here P is equal to P naught 1 plus r to the n power. So P is the percentage. P naught is the initial percentage, which is going to be 100%. 1 is the 100% that we start with. And here we're going to lose 10% of light, so we're going to subtract by 0.1. And n is the number of mirrors. From there, we can simplify this to just P equals 100, 0.9 to the n power. In part B, we can set P to be 43, and it's going to be equal to 100, and then 0.9 to the n power. So if we divide both sides by 100, we'll have 0.43 is equal to 0.9 to the n power. We can solve this using logarithms. So log 0.43 is equal to log we'll also apply the power rule here, and then log 9. So n is going to be equal to the quotient log 0.43 divided by log 0.9. Sorry about that. And using a calculator to evaluate this, we'll get 8.010 and so forth. And so we can say that the answer is about 8 mirrors. Let's move on to number 2. So here we are to simplify a logarithmic expression without using a calculator. So we have log 8,000 divided by 49. So first thing we can do here is to apply the quotient rule. So we have log 8,000 minus log 49. From there, you can use the product rule to separate the first term. So log 8 plus log 1,000. And then for the last term, we can rewrite 49 as 7 squared. Okay. Likewise, we can rewrite 8 as 2 cubed. So we can have something that looks like this. So from there, we can use the power rule to move the 3 to the front of the first logarithm. We can rewrite log 1,000 as 3, since the base is 10 there. And we can rewrite the last logarithm as 2 log 7. And then after that, we can substitute in the values of log 2 and log 7 that were given. So this would be 0.3010 plus 3, and then subtract 2, and then the approximate value of log 7 was 0.8454. 0.51, and this could be multiplied out, of course, and we'll get an answer of 2.2128. And that's it. Okay, let's move on to number 3. Write as a single logarithm. Okay. So in this case, we can use the power rule first. Rewrite the first logarithm as log x minus 8 squared, then plus log x minus 5 squared. And then the last logarithm, we are actually going to factor the x squared minus 13x plus 40. So we'll get x minus 8 and x minus 5. Now, notice that we are adding two logarithms together and then subtracting a third one. So what we can do, of course, is rewrite this whole thing as a single logarithm. So this will be log x minus 8 squared times x minus 5 squared all over x minus 8, x minus 5. And after simplifying everything, we'll get a single logarithm of log x minus 8, x minus 5 only. And that is the answer. So we could, of course, multiply the two binomials back together, but that doesn't seem completely necessary. So that's a good answer right here. You may also be wondering about the restrictions. So in this case, the first logarithm gives us the restriction x is greater than 8. The second one gives us x is greater than 5. And finally, the last restriction is x is less than 5. And x is greater than 8. And recall that when we look at restrictions, we look at the most restrictive one. And so in this case, the restriction is simply going to be x is greater than 8. Okay, which is the only restriction that works for all three of the arguments. Okay, let's move on to problem number 4. Okay, so already graphed the function here. We can just make a table of values. Notice that we have 1, 0. The logarithm of base 2, in base 2 of 1 is 0. And then we have 2, 1. Since log base 2 of 2 is 1, log base 2 of 4 is 2, and finally log base 2 of 8 is 3. And for the numbers between 0 and 1, log base 2 of 1/2 is equal to -1. And one more point here, log base 2 of a quarter was -2. So that's one way to graph this function. The intercept, so here we can state that there's no y-intercepts because of the asymptote. There is x-intercept at 1, 0. Okay, the vertical asymptote, as we said before, just x equals 0. And finally, the domain and range. The domain is x is greater than 0 because the argument needs to be greater than 0. And the range is actually all real numbers. And that's it. So just a review on what a logarithmic function should look like, this problem. Let's move on to problem number 5. Okay, so here what we can do is to isolate the transformation that affects x and y. So so we can rewrite the function as y minus 2, and this would be all multiplied by 1/3 is equal to log base 6 of -3 and then x plus 6. Okay, so what this tells us is that the y variable started as y and became 1/3 y minus 2, which means there was a vertical stretch by 3, and the graph was moved up 2 spaces. And then we can examine what happened to the x variable as well. So the x variable became -3 x plus 6. So that's 3 transformations altogether. There's a reflection over the y-axis. Okay. There is a horizontal stretch by 1/3. And finally, the graph was moved to the left 6 spaces. Okay. So from there, we can use a table of values for the original function first. So let's write this in a different color. So the original function would have been y equals to log base 6 of x. We have x and y here. So let's say we can have 1/36 would have given us -2, 1/6, -1, 1 would have given us 0, and then 6 would match with 2, and then finally 36 would have matched with, 6 would have matched with 1, sorry about that. And then finally, this is 2 here. And then we can apply the transformation to each one of these numbers. Just going to write this in red next to it. Right here. Okay, so for example, the 1/36, it's going to become quite messy actually. We reflect it over the y-axis, so it becomes -1/36. Then it is horizontally stretched by 1/3, so it will become -1/108. And then finally, we subtract 6 from that, and as a result, we'll get -649 over 108. The y value was -2, is vertically stretched by 3, so we get -6, and then up 2, so -4. And then we can do the same thing. So 1/6, again, reflected over the y-axis gives us -1/6. After that, we horizontally stretch by 1/3, so that will be negative 1 over 18. And then we subtract 6 once again, so that will give us negative 109 over 18. And then the negative 1 here for the y value will become negative 3, and then plus 2 is negative 1. And so if we went through and did this with every point, the next one is 1, again becomes negative 1, then negative 1/3, and then we subtract 6, so that will be negative 19 over 3. The y value will simply be 2. And just going to write down the next couple of points, so negative 8 and 5, and finally the last point, negative 18 and 8. Okay, and then afterwards we can plot those on the grid and draw the graph. Some additional points may be needed, but this is what the graph would look like at the end in green, right here. And we also have the asymptote, and this of course will be x is equal to negative 6, because the whole graph was moved 6 spaces to the left. Okay, so let's move on to number 6. Okay, so use algebra to determine the x-intercept. So quite simply then, in this case, we can let y equals 0. So this would just be 4 log base 2 of x plus 12. So if we subtract by 12 and divide by 3 on both sides, we get negative 3 is equal to log base 2 of x. We can rewrite this in exponential form, so 2 to the negative 3 power is equal to x. And so x is going to be equal to 1 over 8 as the x-intercept. And that's it. So that is the conclusion of the problem section. The most challenging problems in this section is probably the graphing problems. Just the graphing problem number 5. And that's about it. So thank you again for listening.